Hi, I'm Matt Turk. Welcome to the MAD Podcast. Today my guest is Harrison Chase, co-founder and CEO of LangChain. Harrison has been one of the key figures in the rise of AI infrastructure and agents, from LangChain's early days as an open-source framework to LangGraph, Deep Agents, Langsmith, and Agent Builder. This episode is a deep dive into the frontier of the AI stack. As AI moves from simple prompts to agents that can plan, use tools, write code, and manage memory, the big question is, what new infrastructure is required? Please enjoy this great conversation with Harrison Chase. Hey Harrison, good to see you.
Thank you for having me. I'm excited to be here.
For anyone watching on YouTube or Spotify, you'll notice we're in a different venue today. We're not in the usual studio, we're at the Chase Center in San Francisco, recording as part of the Daytona Compute Conference. A good place to start would be to frame the evolution of agents over the last few years. There was a huge moment, I think around the holidays, December and January, when everyone kind of realized at the same time how far agents had come in just a few months. So help us compare the first generation of agents to what we have today.
A lot of the ideas behind today's agents were actually present in the early days. The difference was that the models just didn't work back then. LangChain came out maybe half a month or a month before ChatGPT, and one of the main things we added at the start was this idea of running an LLM in a loop and calling tools. There's a great paper called React that said to do exactly that, and it worked on their dataset, which was Wikipedia question answering, but it didn't work in the real world. Then in March, AutoGPT came out, and it was the same thing. It ran in a loop called tools, and in a lot of ways it was really a precursor to something like Claude Code. The way I describe the trajectory of agents since then is that there was this core, really simple idea: just run the LLM in a loop, give it a prompt, some instructions, and a bunch of tools. But that didn't work all that well. So people ended up building scaffolding around the models to make them behave in a more predictable and reliable way. That's why at LangChain we built LangGraph, another framework aimed at graph-like workflows, giving more structure. When you really want super high reliability, you want to use something like that. But sometime around November or December, with some of the newest Claude models, the models just got really good, and you kind of discovered that they could actually just run in a loop. And a lot of this wasn't just the models, it was also the harness around the models. If you look at things that came out about a year ago, Claude Code, Manus, Deep Research, they all had the same thing: running the model in a loop, having it call tools, write code, and read and write files. So I think two things basically happened. The models got better, but we also started to discover these primitives of a harness that would really let the models do their best work. And over the break, people basically realized that, and we saw an explosion of people building agents for all kinds of different things using these same core primitives.
What kind of agents are we talking about? Are we talking about coding agents? I think you said somewhere that every agent should be a coding agent.
So we see a divergence between two different types of agents. One is conversational agents, think customer support, customer experience, chatbots. These require really low latency, voice is often the medium they interact through, and they don't do a ton of tool calling. Maybe one or two because any more would take too long. But then there's another style, which Sequoia coined a name for: long horizon agents. I really like that. They can operate over long horizons, do some planning, and maintain coherence. And yes, a lot of them end up looking like coding agents. There are probably a few reasons for that. One, code is just really useful. You can use it to do a bunch of different things like parsing text files or doing things programmatically. If you want to loop over 100 different files rather than making 100 different tool calls, you can just write a script that does that. So code is really generally useful, but then on top of that, the models are trained on code, and that's why all the big model labs have leaned into it.